Hey there, science fans, have you ever noticed how shadows are always around us? They're like sneaky little siblings, always tagging along. But shadows are much more than just dark spots. They can teach us about light, physics, and even the universe. Think about it. When you walk outside on a sunny day, your shadow walks right beside you. It grows longer in the morning and evening, then shrinks at midday. Why is that? We'll uncover the secrets of shadows together. Get ready to explore the hidden lives of shadows. We'll learn how they form, why they change shape, and what they can tell us about the world around us. Let's get started. So how do shadows actually form? It all comes down to light. Light travels in straight lines. Imagine tiny beams of light, like laser beams, shooting out in all directions. When these light beams hit something solid, like you or a tree, they can't go through. That's where the shadow comes in. It's the area behind the object where the light beams are blocked. The shape of the shadow depends on the shape of the object blocking the light. The closer the object is to the light source, the bigger and blurrier the shadow. Move the object farther away and the shadow gets smaller and sharper. Cool, right? Now here's where things get really interesting. Light can act like both a wave and a particle. This is called wave-particle duality. It's one of the amazing mysteries of physics. Think of waves in the ocean going up and down. Light can act like that, bending around corners and spreading out. But light can also act like tiny packets of energy called photons. These photons are like little bullets of light. How can light be both a wave and a particle? That's a question that has puzzled scientists for centuries. But by studying shadows, we can see evidence for both sides of light's personality. Let's do a little experiment to see light's dual nature in action. You'll need a flashlight, a piece of cardboard, and a dark room. Cut 2 small slits close together in the cardboard. Shine the flashlight at the slits onto a wall. What do you see? You should see a pattern of bright and dark lines. That's called an interference pattern, and it's evidence of light acting like a wave. Now, dim the flashlight way down. You might even need to cover it with a cloth to let just a tiny bit of light through. Watch closely. You might see individual dots of light hitting the wall instead of waves. Those are photons acting like particles. Section 5. Shadows and the photoelectric effect. Light's particle nature is what makes things like solar panels work. It's all thanks to a phenomenon called the photoelectric effect. Imagine shining a light on a metal plate. If the light is just right, meaning it has enough energy, it can actually knock electrons loose from the metal. Those electrons can then be harnessed to create an electrical current. This is exactly how solar panels generate electricity. Light from the sun, made of those little energy packets called photons, hits the solar panel and knocks electrons loose. The panel's design then directs those electrons, creating a flow of electricity. Section 6. Solar power harnessing light with shadows. Think about it. Shadows and solar panels are connected. A shadow is formed when an object blocks light. Solar panels need light to generate electricity. By understanding how shadows form and how light behaves as both a wave and a particle, scientists have been able to develop amazing technologies like solar panels. These panels are helping us move towards a cleaner, more sustainable energy future. So the next time you see a shadow, don't just see darkness. See the potential for clean energy. Shadows are reminders of the incredible power and mystery of light. Section 7. Shadows in culture and art. Throughout history, shadows have captured our imaginations. They've played important roles in mythology, storytelling, and art. Think about shadow puppets. By using just a light source and cut-out figures, you can create moving stories with shadows. Shadow puppetry is a form of entertainment found in cultures all over the world. Artists use shadows to create depth and realism in their paintings and drawings. Photographers use light and shadow to create dramatic effects. Even dancers and actors use shadows to enhance their performances. Section 8. Shadows in science and astronomy. Scientists use shadows to learn about the universe. During a solar eclipse, the moon casts a shadow on the Earth, blocking out the sun. This is a spectacular example of shadows on a cosmic scale. Astronomers can also study the shadows cast by planets as they pass in front of stars. By analyzing these shadows, scientists can learn about the size and composition of distant planets. Shadows truly are windows to the universe. Section 9. The enduring mystery of shadows. Shadows might seem simple at first glance, but as we've discovered, they hold many secrets. From the wave-particle duality of light to the power of solar energy, shadows teach us about the fundamental nature of our world. So next time you see a shadow, take a moment to appreciate its beauty and mystery. Remember, shadows aren't just dark spots, they're reminders of the incredible power and wonder of light. Keep exploring, keep questioning, and keep marveling at the world around us.